Hello everyone, welcome back to my channel or my Shady World. In this video, I will show you how you can graphically represent your correlation matrix via heat map graph. So let's get started. As you can see here, I have imported one Uber based stock data in stock underscore df data frame, and this is how the initial five records looks like, and the date, open, high, low, close, adjusting close and volume. These are the columns of this data file. So now let's create our heat map. So for this, let's first create the correlation matrix. To create that, uh, I will write stock underscore df dot core. Once you write this, I will assign this to particular object to that. So let's write core1 is equal to, and now run this cell. Okay, core1 is done. Now let's see how this core1 looks like. So this is how the correlation matrix has been created for the numerical based on data, because the method that by default is taken as a Pearson correlation coefficient, which is, as you can see, the numeric Pearson correlation coefficient works for the numerical type of data and those who are numeric. So here the date has been the exceptional, it was in the object, so been discarded in this correlation matrix. So this is how you have created a correlation matrix. Now, to have a view, have such kind of an enhanced look using a heat map option, you have to first go and import the very important libraries which are required for any graphical or a visual representation. So for that, you need to first import matplotlib dot py plot, and I will give the alias name as plt, and then I will also import one more library, that is the seaborn as SNS, which is alias name for the seaborn. Why both of these? Because matplotlib is the base visual package, and on the top, the more enhanced visuals if you want, then you have to use the seaborn, which is completely based on the matplotlib. So for us, as we are creating a heat map, you can easily create a heat map using a seaborn library. So I'm running both of them because seaborn is purely based on the matplotlib and the enhanced version. So I will call both this library. So let's run this cell, and okay, so this is how we have run the cell. Now the next step is to create that heat map. So for that, write sns dot heat map at the parenthesis after it, and within the parenthesis I will pass the correlation matrix, and we named it as core1. So I will just simply write core1 and comma, and here I will write the annote is equal to true. The meaning of annote is a annotation. So whatever the value is there, like here 0.99, there is minus 0.22, that has to be there in the heat map. Otherwise, it won't be visible. So after this, I will write plt.show. This will help using this plt show, that will show in front the object. So for that, we will use plt.show, and now run this. So see, this is how it's been created, the heat map. As we have mentioned, a note is equal to true is giving the values out here. And this is how we have to take, like open, open, high, open, low, open, and we can have that same representation. Here the decimal points are little high. They are more than 6 decimal places, but here they have compressed and rounded to the 2 figure. You can also update that, but here let's see what this annotation, if we just simply avoid that, then the by default is the annotation false. So now let's run this cell. You will see it's completely blank, but yeah, this color combination says that something which is light orange, or you can say the cream in color, they are actually more highly correlated, because the values are 0.99. So any scale which is beyond 0.80 to 1, they are the highly correlated variables. So there is a high correlation between these two variables, and anything here with the dark, that black in color, they representing something towards minus zero point 0.2. So anything less than zero point 0.2, that is between 0 to 0 0.2, that is 20%. So 0 0.2 to 0 0.20. So in that, not a person, I'm sorry. So within 0 to 0 0.20, so within that bar, if you say the relationship is giving me such kind of a numbers, as here the volume and open is in negative 0 0.2022. So this gives, they are very low correlation, so this will not impact in overall analysis. So this is how we can have our correlation matrix. So it is always ideal to add the end note is equal to true, so you can have a look like what exactly the numbers are and how it is defined. And to change the size of this heat map, you can also add here at the top plt.figure, and in that pass fig size, because we want to change the size of the figure. So in rows and columns, that how it represents. So here let's say 10 comma 10, let's say, and now run this cell. And as you can see, the width and the height of that particular uh, heat map has been increased. So I will little adjust that because it's not looking good. Yeah, this is how. So this is how you can have your scale, and as a heat map says, they are difference in the colors and the numbers which are being annotated unable. So we are having the matrix as well, matrix number, what the value is, and at what level they are being associated, and the colors are giving you the clear differentiation or the bifurcation, what highly correlated or what the least correlated. I hope you learned this, and I hope you like this video as well. If you really like, then do like, share and subscribe to my channel for more such videos. Please hit the bell icon as well, and thank you so much. See you on the next one.